Okay, let's get started. So today's presentations on our DBT tag, how and speak, is related to this acquisition of SDF, so another company, by DBT. So we are going to talk about what this implies and what changes we're going to be seeing probably in the future on DBT. So this is quite recent. And basically what I'm going to be presenting is not a hands-on demo because the changes are not still rolled out on DBT. So I'm just compiling different aspects that they were mentioned by DBT, so official sources. So they were giving different blog posts and publications related to how these changes are going to be impacting on DBT. And this is what I'm going to be presenting today. Hopefully you find it interesting. I think it's quite interesting and relevant to how DBT is going to be in the near future. So if you are new around here, the DBT talks are repeated every month, the first Thursday of every month. Yeah, brief presentation about me. I'm Hernando Ale. I'm a senior consultant here at Scalefree with experience in business consulting in different areas, data warehousing, business intelligence, analytics, and strategic planning. I have master degree in business analytics and certifications on DBT, Snowflake, and also Data Vault, among others. And yes, you can also see my core competencies. What are we going to be, or how we're going to organize the presentation today? Usually our presentations are more hands-on, but I think this one is going to be more like just a presentation. There is no practical part into it, but it could be also interesting for you as it's still not, like the changes are not still available on DBT, but they are going to be there soon. And there were a lot of Catter posts about this, but nothing that brings everything together. So that was my idea about this presentation. So I'm going to give a brief introduction and some background and context so we understand what problem is trying to solve this acquisition and implementation of SDF, this new company. The acquisition explained, this also is going to be quite brief, and the core of my presentation is going to be these 4 and 5 parts of the agenda. Is introducing SDF technology, so actually what it does, and how it's going to impact on DBT ecosystem. And then I'd like to briefly discuss some future implications. So the introduction is that DBT Labs acquire SDF Labs, which is also called with the labs in the names. And what they say is that SDF brings SQL comprehension technology. We are going to talk about what this means. But they've mentioned that it will bring multiple upgrades related to faster DBT project compilation, better developer experience, highest fidelity lineage. But maybe you are asking, if you saw this news, it's like how this will impact my workflow actually or in practice. A really brief background of what DBT does, isn't it? So let's discuss it. DBT simplifies the creation of models as simple SQL statements. We see, as we always present DBT is the T, so the transformation part on your ELT pipeline. I will argue that now is a bit more than that. But yeah, basically it's focused on this transformation part of our ELT pipeline. What DBT did was to simplify this process. Before it was more like related to or done by highly technical data engineers. And now everyone who understands SQL, which is a fairly simple language, can create data pipelines. So they create also like this analytics engineering position somewhere in between a data analyst and a data engineer. And we know that DBT historically just treats SQL as strings. So it doesn't understand the SQL that you are writing. You just compile your SQL and send it to your database, the database that you're using for your data platform, as you can see here. So DBT sits on top of it, but it doesn't interpret your SQL. For that, you need to send it to your data warehouse, to your data platform. Then we know that after that, there was this need of more dynamic capabilities, and Shinsha was introduced as this also like language, quite Pythonic. And in this case, we can start to work with our ref functions, with variables, with some configuration, and like we can establish more complex logics in our SQL, for instance, the for loops of some conditions. So this it was done with the introduction of Shinsha. So if you work with DBT, probably you are working with Shinsha when we are using the curly brackets. And after that, it was the natural step to that packages were created. So these blocks of already pre-made macros that you can use and reuse and also adapt on your projects. So these are the packages that we can use on our DBT projects. But still, DBT could not understand the SQL that the users were writing. And as I just told you, it just compile it and send it to the data platform. This is the status right now of DBT. So then we have the acquisition. It was quite recent. If I'm not wrong, it was on January when we had also this message from the CEO and founder of DBT Labs, where he said, we are acquiring SDF to bring SQL comprehension into DBT and usher a new era of what's possible for analytics, supercharging developer productivity and heightening data quality, all while optimizing data platform costs. So here he summarized what this is going, like how it's going to impact, but now we are going to separate this affirmation, this quote, into different parts and see what it implies. SDF technology. Let's talk about what SDF developed. Yeah, I'm going to repeat myself because this is the big change. DBT historically treats SQL as a string. So now SDF sees objects, types, syntax, and semantics. So what SDF does, and you can see it on the image on the right, it sits somewhere in between our developer section and our data platforms, as you see on the left. And it can emulate the SQL compilers native to our data platforms. So you can imagine this, something similar as a virtual machine. But instead of this virtual machine is emulating hardware, it's emulating the SQL compilers of your data platform of choice. This is going to be quite powerful because it will allow to provide feedback of your SQL before executing it. And then we can do different stuff like catching breaking changes as part of the development process. So we will see that we can iterate faster with that. We don't need to do the typical step of like, we write our SQL, we send it to the database compiles it and run it against your data, and then you receive your, let's say you have an error, you receive some error message from your database. We'll see that SDF, we will be emulating this SQL compiler from your database, and it will be able to catch this error before you are sending the SQL to your database. We will see also, like, we will discuss the different implications this can have in your workflow. So the problem, DBT creates SQL, but it doesn't understand the semantics of it. Each data platform vendor has created a unique SQL dialect. So if you work with different data platforms during your lifespan, like your professional career, you know that the SQL flavor of one data platform is not exactly the same as the SQL flavor of another data platform. So these are different dialects as we refer here. And also you will see that different data platforms, they have different ways to, for instance, optimize queries. They could be columnar databases, they could be row-oriented databases. So there are differences between how this SQL is compiled and run on the depending of these databases or data platforms. So we need to understand that compilers are programs that translate this high-level language into a logical plan. And historically, this capability has been contained into the data warehouse or into the data platform that we are using. Now we will see that SDF will have some capabilities of doing that for us. So then, yeah, SDF appears. This is how they show, like, in which steps SDF can, like, provide some value. And so SDF will unlock multi-dialect local SQL compilation. Multi-dialect because it will be able to emulate the compilation in different data platforms. So what will this imply for us? It will have real-time impact analysis. You don't need to wait for your database to run the query against your data. You will have some feedback instantly. Error reporting, we will see some examples. Developers move faster. This is what I was saying, that we can iterate faster. And compute cost reduction, we will see. Like, I think it's quite straightforward in a general basis. We don't need to run all our queries all the time against our database to validate it. So now we have the validation before running it into the database. This is like quite straightforward cost reduction, isn't it? We don't need to run. We don't have the computational cost of running this SQL until you end up wanting to send it to your data platform. But let's go a bit deeper on what SQL comprehension implies. And I was adding the sources. These again are all DBT official posts. I didn't want to go to another places, so we have all because it's so new, so we have all the official information. So SQL comprehension implies different things. For instance, identify constituent parts of a query. We are going to see what that look like. Create structured artifacts for their own use or for the other tools to consume in turn. Also, check whether the SQL is valid. Understand what will happen when the query runs. Things like what column will be created, what do they have, and what data definition language, like this create, drop, alter, or truncate statements is involved in this query. Because usually, if you're working with DBT, you're just writing a select statement, isn't it? But when you're sending it to the data platform, it's creating these DDL statements. And then finally, execute the query and return the data. So we will see that when we talk about SQL comprehensions, we have different levels of SQL comprehensions. And this is good to start to understand better what is happening when you're running a query. And it's quite, as I was reading, it's quite much more complex and deep of maybe as what it feels like. So the first level, which would be like a higher level from 1 to 3, going deeper, is this parsing level, where the artifact that is being created is a syntax tree. And you know what symbols are used in a query, for instance. We're going to see a real example of this. Then the second level is compiling, is creating this logical plan. So in this part is where SDF plus DBT will bring us superpowers, because DBT already have this tag. You remember, like the directed acyclical graph, where we know already the dependencies between our model with our ref functions. But now we also will have these query logical plans. And for instance, we will know what types are used in a query and how they change regardless of their origin. So we can have this impact analysis between our different models. So we have some synergy between DBT, what DBT already provided, which was our DAG, directed acyclical graph. But now SDF will bring these compiling capabilities, like real compiling, and the logical plan into it. And then finally, we have the third level, which is the deepest level, we can say, called executing, which is basically everything that we said before, and also having a physical plan and the query results. This is basically what a database does, isn't it? Just to run your query against your actual data. So an example that they provide on this post, DBT provides, imagine we have these inputs, select data, and we have like the different parameters into it. The first is the date part, the second is the integer, and then we have the date or time expression, and then some alias as new day. So the three levels, how they will look like. At level 1, we have this baseline comprehension of SQL. So we can parse these strings of SQL into a syntax tree, and it's possible to reason about the components of a query and identify if they are written syntactically wrong or not, if they are is correct or not. So here we can catch errors before they happen against your database on the syntax level. Then we have the compiler, which adds the parser level, but in this case, we also have the logical plan. And a logical plan knows about every function that's called in your query, the data types that are being passed into them, and what each of these columns will look like as a result of running this query. So here, I think this is where we reach some kind of superpower with DBT and SDF, because we are going to be able to catch almost every error before running our code. So we are going to be writing our code, and we will have some error message that will pop up. In this example, as you see in the middle, the compiler, we can imagine that DBT with these SDF capabilities will know that, for instance, on Snowflake, let's say it's our data platform, our function, our data function, has 3 arguments, and in this order, it has the date part, the integer, and the date or time expression. So it will expect like these particular arguments inside our function, and if we are doing something wrong, it will tell us. Imagine instead of an integer, we are just inputting something different. It will tell us that we are doing something wrong. Before that, on DBT, right now, if you are developing on DBT, you will make the mistake and you will run it against your database, and then you will get the error, because so far what it's doing is just compiling your code and sending it to your database. So this is going to be really useful to increase our productivity as developers, actually, to get the errors, to catch the errors faster, and to save money, because we are not running our database to catch this error, to trigger the error against the database. Finally, the executor, which is the deepest level, as we were saying, is basically actually executing a query and modifying our data. So this is the database level that we know. We validate everything against the data itself. Now let's talk about more like clear examples and points on how it's going to impact on DBT. So how DBT is presenting is that it will impact in different areas related to data velocity, developer efficiency, data quality and trust, cost optimization, as we mentioned, and richer lineage. I like the image that is like on the lower part here, because it gives you this idea. Now, SDF will sit in between our local development environment and our cloud database, and it will help us to get the error, to catch the error. We don't need to send the query all the way to the database until it's a valid query. So it will tell us that there is some error, and we can fix it before sending it to the database. This is what I was saying, like in a visual way, what I was saying during the whole presentation. It will sit in between, and once our query is correctly written, we send it to our database, and we run it against our data, of course. Then also DBT, they mentioned that there are like different benefits related to validate, analyze, and optimize our workflows. So let's start with some examples for each of them. For validate is one of the most straightforward example. The questions that we are going to be answering is, will my SQL really work? Before that, you are writing a SQL that maybe is missing something, and you need to send it to a database. And then when it fails, you will get the error message from your database. Now we will have something like this. This is an example, and you can see that this is incorrect. The SQL is incorrect because we are trying to round something that is a Boolean value, true, false. So we cannot run that. So we will have some error message that you cannot do this. And you say this is quite obvious. But also the good thing is going to be that usually we are not rounding literal value, isn't it? Like, for instance, this Boolean value. You would never round a Boolean value, but we are not rounding just a value directly. Usually we are rounding a column, isn't it? And maybe that column comes from another model that is somewhere upstream in our DAG. So the good thing about this implementation of SDF in the loop is that, let's say that we modify this column that it was a numeric value before, and we change it to a Boolean because, I don't know, we need to change it to a Boolean. It will identify how it will impact downstream in our select round and our statement. So it will tell us also how these changes upstream will impact downstream on a columnar level basis. This is called impact analysis, and it's also going to be really useful to quickly know when you are making changes, what are the downstream dependencies and the impact that you can do, and if you are breaking something related to your SQL that is not going to run, is not going to work, because it doesn't make sense as rounding a Boolean value. So we will catch these breaks that will happen downstream, but on the go. We don't need to run our query because this combination of knowing our query logical plan and having our directed acyclical graph, this is the powerful thing. We will have all these dependencies and we know what will happen, how it's going to be the impact downstream in our models. Continue on this idea, we talk also the impact on DBT relating to analyze. In this case, they talk about generating precise column level lineage. And what does this implies? It implies different things. For instance, to have a full and accurate understanding of the column dependencies in your data pipeline. We already have some column level lineage on DBT available, at least on DBT Cloud. But now we will have this impact analysis, as I was telling before. So it's going to inform the debugging workflows and this downstream impact analysis. So we make some change upstream and we will know if it's breaking something downstream and it will warn us before sending our query against our database. Yeah, they also mentioned that another advantage of this is that we will be able to create even slimmer continuous integration builds. So remember that we have this defer configuration with DBT, which is quite popular, where we are just creating what it changed and all the impacts that had downstream. So far, it's quite general. So if the model is related downstream, it's going to be recreated. But now we can know that at a column level lineage, if only where we are going to only be building downstream the models if they depend on the exact columns that they were changed. So we will have even slimmer CI builds. We have a slim CI builds, but now it's going to be even slimmer. So we are going to be even more precise on running when you are making some change and they're like downstream impacts when it's necessary. So you don't need to run like all the models that they are related downstream, but the models that they will have some impacts at a column level lineage. And then I think this one is really interesting. I'm still not sure how it's going to look like, but they talk about metadata propagation. So propagate the metadata all the way from ingestion to consumption, unlocking naming, test, description, propagation. So one example that they provide is related to PII, so personal identifiable information tagging, because normally you have to tag every column manually all the time for this personal information and update it as your warehouse is changing. Now with SDF, you can propagate those types through the warehouse. So it will help us to not repeat ourselves and it will do it automatically, this tagging. Finally, we were talking about the impact on DBT related to optimize. This is how they call it. And we will see that there are like two approaches to query optimizations. The first one that they mention is to optimize the query for the engine. So, and I already started with an examples, but for you to know, as I was saying at the very beginning, each engine has a different SQL flavor, as I was saying, and also has different ways to optimize queries, isn't it? If you work with Snowflake, it's not the same as BigQuery, it's not the same as MicroSQL Server. So an example that they provide is, imagine that you're working, I think could be with Snowflake that works with micro partitions. And we have this query pruning, isn't it? Like a way that the database optimize your queries by like, you can have some configuration on it, but it also does it by itself. It's scanning this subset of data that is referred to the query. So it doesn't scan the whole data set, it just scans what is referred to the query. And this is called query pruning, and it's done by leveraging what is called micro partitions. So on the example, they say like, you could be, without knowing, creating a query that breaks these performance optimizations relating to your engine, to the database that or data platform that you're using. In this example, we are casting a date into our chart to make this comparison, this work condition. And it will prevent our data platform from pruning our query in this particular example because it's using this column for the pruning. But if we change it from a date format into a bar chart, the data platform won't be able to optimize by query pruning. It won't optimize our query. So the idea is that the SDF will be able to catch that you are doing a change that in this case, and this is the difference from the previous example, is that it's not breaking. It's still a valid query. It's not breaking anything. So you still can send it to your database and it will run it and it will be fine. But it's not the most optimal way to do it. So it will tell you, because it will understand your SQL and the context of the data platform, and it can alert you beforehand so that you're affecting performance. So a quick fix would be that to not change this data typecasting that we're doing. And then, so it's not a breaking, like a change that it was breaking our SQL before. It's not something that we will get an error message, but we were affecting performance. And SDF will help us also to optimize our queries related to the context of our data platform. Finally, we are talking about optimizing, and we have two approaches. And in this second approach is optimize the choice of the engine. So here we can talk about having multiple platforms. So let's say you work with more than one data platform. And this, because of this knowledge that SDF will, and DBT in this case, isn't it, will understand your SQL query in the context of your data platform, it can choose where to run it and where it's going to be more optimal. So we can optimize also your DAGs, your directed acyclical graph production. Another way to optimize, it will be to dynamically change your warehouse size for your DAG execution. So basically, here, usually, like when we are running any type of query or where we are setting the configuration of our data warehouse, we need to choose between some kind of trade-off where we have the cost and the performance. The most performance we wanted, the higher the warehouse, the more costly it's going to be. The lower the warehouse, the performance is going to go low, it's going to be lower, and the cost is going to be lower. But there is some balance that we need to do and some analysis. Sometimes it's quite complex. So now also SDF will provide some help on optimizing your query related to the context of your platform and being able to dynamically adjust your warehouse size related to the query you're running against your database. So this is another way that we can use these new capabilities that DBT is going to have to optimize our queries and our DAG executions. So I'm already at the end. I invite you to see the different posts of DBT. They are much deeper of what you like, because they are like multiple. To see them, they are like quite interesting. It's not only about SDF, but it's also about getting deeper into these different levels of SQL query comprehension, the parser, the compiler, the executor. I think they're like really good posts. So what are the future implications? So right now it's not available, but the integration is on the making. So we should see it in the near future. Probably they are going to be rolling out at different degrees. So we are going to be seeing some changes in this year. I think this is quite interesting for people who work with DBT Core also. This is a quote that I catch also from their official channels. It's not gossip. They say that while SDF won't be included as part of the Apache 2.0 code base, we plan to make meaningful parts of SDF capabilities, so the capabilities that we were discussing today, available to all DBT users, whether you are using DBT Core or DBT Cloud. I think that's also really cool. It's not that you will need to have DBT Cloud to have all the functionalities. We still don't know which functionalities are going to be available on DBT Core and which ones are only going to be available on DBT Cloud. But at least, as we can see so far, there is some intention to roll some of these capabilities also on DBT Core. Finally, SDF brings faster performance, optimized data platform costs, and better data lineage to DBT, all without changing the code in your project. So we don't need to do anything. I guess our user interface is going to change a bit. We are going to be able to see these errors faster, and we are going to become much more performant. So that was it. Now, as you know, like you can leave some question, but yeah, probably like this is what we know so far. That's the truth. We don't know exactly how it's going to look like, and this is a compilation of like what they communicated so far. I think is really promising for everyone who works on DBT. So we will see how it look like in the near future. Then from Scale-Free, we have some invitations for you. We have different courses, for instance, DBT and Data Vault 2.0. This is quite relevant to our presentation because it's a combination of the data build tool on the implementation of Data Vault 2.0, which are also at Scale-Free were specialists. Also, we have trainings related to Data Vault 2.0, automation with Wordscape workshop, and Agile data warehousing, a discipline hybrid method. I also recommend you. You will receive these recordings, so you can come back here, and you can always go to our website, scalefree.com, to check all the information I'm presenting right now. Is everything you will find it there. So as usual, I invite you to keep coming to our DBT talks. We do it once every month, every Thursday, first Thursday of every month. You can submit questions on our website. And yeah, hope to see you there in the future. Thank you very much.